rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to S. Chand Academy, the official YouTube channel of S. Chand Publishing. The book here is Mathematics for IIT-JEE Main and Advanced by ML Khanna sir, and I am Subuh Nadeem to present you the videos. So here we have the next chapter before us, which is chapter number 27. It is functions. Let us see some overview of this chapter. So let us talk about definition of a function. So how do we define a function? We define a function such that for every element in set A, there is unique image in set B. So there is a mapping, and this mapping satisfies this relation. That is a set A and a set B, and then for every one of these there is a unique image like this. So this is called a function. Now there is a domain of a function. What is a domain of a function? Domain of a function is those values of x for which fx is real, as we are talking about real valued function. And what is the range? Range is the output, that is the values of fx. This is the range, and the codomain is the set B here. This is the codomain. Now we have this as the domain, this as the range, and then we have one function and many function. What is a one function? One function is a function for which for every image we have a unique pre-image. So we can say that these type of functions are one functions. And if it is something like this, that a image has a two pre-images, then it is a many function. So the one function is actually represented like this in the roster diagram or the arrow diagram, and that many function can be written like this. But you can see that for one function, f of x1 is equal to f of x2, which will implies that x1 is equal to x2. This is how you can write the definition of one function. And for many function, this set will not be satisfied for all of the results. Next we have is one onto function and into function. So if we talk about onto function and into function, so what is onto and into function? If we have a function such that its codomain is equal to its range, if codomain is equal to its range, then it is onto function. And if the codomain, for example, these are the elements on the set B and these are mapped like this, and this particular element has no pre-image, so we will say that here codomain is not equal to range. So this will become an into function. But an onto function, we have codomain as range. That is, all the elements in the second set will have a pre-image. Now we come to inverse function. So what is an inverse function? Inverse function is a function which is written like this, that if we have f inverse of x, then this means that f of f inverse of x is equal to x. Or we can say that if gx is a function which is called to be f inverse of x, then g of fx is equal to x also. Like we have fx is equal to x square, where x is greater than equal to 0, and we are taking inverse of this, that will be root over x. Then we say that these are the functions which are inverse of each other. So if this is a function x square, then this is another function root over x, and these are inverse of each other, And what we can observe for inverse functions, that there are mirror image about the line y is equal to x, and even if they meet at y is equal to x. Now we come to the next part, some of the questions. So here it is said, let fx is equal to 1 if x is a rational number and 0 if x is an irrational number. Be a function from R to R where R is the set of real numbers. Find f of 1 by 3. So 1 by 3, what is type of this? It is a rational number. 1 by 3 is a rational number. So this will give you an output 1. What is f of root 7? So root 7 is an irrational number. So it will give you 0. What is f of 1.4327? So this is f of 1.4327. It is a composite function. So this is a rational number. 1.4327, it is a terminating decimal, it is a rational number. So its value will be 1. And then further f of 1. 1 is also a rational number. This will give you 1. If we talk about this, this is f of root 3. Now root 3 is an irrational number and f of x is 0 for it. So this will become f of 0. Now f of 0, if you take x is equal to 0, it is a rational number. So f of x will be equal to 1. So this is how we find the different values here. Now let us come to the next question. If fx is equal to cos of greatest integer of pi square x plus cos of minus pi square greatest integer x, where x box is standing here for the greatest integer function, then evaluate f of pi by 2, f of pi, f of minus pi, f of pi by 4. So let us start with f of pi by 2. So if we take f of pi by 2, what will happen? This will become cos of pi square greatest integer pi by 2 plus cos of minus pi square. This is also greatest integer pi by 2. So in all the cases you have to find here the greatest integer of pi square. What is the greatest integer of pi square? Since it is a value 3.14 square, which is 9 point something. So this you can say is 9. So cos 9 pi by 2. And then we have minus 9 point something, which is minus 10. So this will be cos of 10 pi by 2, because minus sign will be absorbed inside the cos. So this will become cos 9 pi by 2, which is actually cos of 4 pi plus pi by 2. And this another part is cos of 5 pi. So cos of 4 pi plus pi by 2 is cos pi by 2, which is actually 0. And cos of 5 pi will be cos of pi, that will be equal to minus 1. So this value is minus 1. Now if we talk about f of pi, so f of pi will be cos 9 pi plus cos 10 pi, like this, because this value already is 9, this value is already 10 here. What is cos 9 pi? As we have got earlier also, that is cos 9 pi is 8 pi plus pi. And what is cos pi? Because 8 pi will be cos pi only. So this will become minus 1. And cos 10 pi will be 1. So this value will come out to be 0. If we take f of minus pi, what will happen? So this will become cos of minus 9 pi. Right, students? And this will become cos of minus 10 pi. And since minus sign can be absorbed in the cos, so this will also give you 0, as it will give you minus 1 plus 1. If we talk about f of pi by 4, what will happen? F of pi by 4 is cos of 9 pi by 4 plus cos of 10 pi by 4. Now if you take the values here, cos 9 pi by 4 is actually 2 pi plus pi by 4. This is cos of 2 pi plus pi by 4, right? And this is actually cos of 5 pi by 2. Now cos of 2 pi plus pi by 4 is cos of pi by 4, which is 1 by root 2. and cos of 5 pi by 2 is cos of 2 pi minus pi by 2, which is cos pi by 2 again. So that will become 0. So this will be 1 by root 2. So this is the value which we are getting here of these functions. Now let us come to the next question here. A real valued function is given and it is defined by fx is equal to x plus 1 whole square minus 1, where x is greater than equal to minus 1. Then the set A is equal to x such that fx is equal to f inverse x is equal to 0 comma minus 1. So what we will do here is, we will again see here that it is a question of inverse function, and if we equate fx with f inverse of x, so we can say that fx is equal to f inverse of x is equal to x actually, because both the functions will meet on the line y is equal to x. So we can say x plus 1 whole square minus 1, which is the function, is equal to x. So this will become x square plus 2x, 1 will cancel, and this will be equal to x. So x square plus x is equal to 0. So we get x is equal to 0 and minus 1. So these two values are there which we see over here. Now let us come to the next question. You have to find the domain of this one. This question is there and you have to find its domain. So in this question, if you want to find its domain, what will happen? First of all, under root is there. So you have to understand that it should be a positive quantity. This should be a positive quantity, or it could be 0 also. Further, mod of x is greater than 0, that we know, but we cannot take equal to 0 because it is in the denominator. So x is not equal to 0. This we have to keep in mind. Another thing is log of mod of x minus 2 to the base 0.3. This value also has to be positive because the ratio will have to be positive and denominator is already positive. Now this is greater than 0, which means mod of x minus 2 is less than 1. That is 0.3 to the power 0 and the base is 0.3, which is less than 1. So you will see that the inequality sign will change. So this will become x minus 2 between 1 and minus 1, or you can say x is between 3 and 1. What else you have to keep in mind is that this value, which is the input of log, that cannot be equal to 0. So x is not equal to 2. So considering all the conditions, this is the first condition, this is the second condition, and this is the third condition. We can also say that log of this could be equal to 0 because under root can take equal to sign also. So equality could also be there. So we can include them. So what we say finally is the interval is x belonging to 1, 2 union 2, 3, if that we take the intersection of all of them. Now let us come to the next question. The function fx is equal to cos of sin x plus sin inverse 1 plus x square by 2x. You have to find its domain. So again you have to find its domain. In order to find its domain, what we will do? We will see that the under root function over here is cos of sin x, and that has to be positive, where sin x can have value between 1 and minus 1. So cos of sin x will have value always greater than 0 because we know that cos graph is like this, and if we take the input from minus 1 to 1, minus 1 is here, 1 is here before pi by 2. So the cos part is basically giving this output, which is positive. And if we take this function, then we have 1 plus x square by 2x between 1 and minus 1. Now let us solve it. So when we will solve it, what will happen? We will take two cases. One is 1 plus x square and you will take minus 1 there. So plus 2x by 2x is greater than equal to 0. So x plus 1 whole square by 2x is greater than equal to 0. Now we know that x plus 1 whole square is always greater than equal to 0. So what we have to say is x is also greater than 0. So if we take x greater than 0, it will be satisfied, right? Okay. Now another condition is 1 plus x square minus 2x by 2x less than equal to 0. It will give 1 minus x square by 2x less than equal to 0. Now if we see here, 1 minus x square is always less than equal to 0, greater than equal to 0. So the denominator x should be less than 0. But denominator x is less than 0, then this is okay. But you have to find the intersection of both of them. So when you take the intersection of them, you won't find any value. You can cross check also. For example, you take x is equal to half. So that value will become 1 plus 1 by 4, 5 by 4, and that is greater than 1. So that you cannot take. So there is no domain. So this is 5. Now let us come to the next question. It says range of fx of this function is. So we take it as y. Y is x square plus x plus 2 upon x square plus x plus 1. Now we cross multiply and write it as 1 minus y x square plus 1 minus y x plus 2 minus y is equal to 0. We write it like this. Now if this x is real number from minus infinity to infinity, then this quadratic in x will have the real roots, which means discriminant is greater than equal to 0. So 1 minus y whole square is actually b square minus 4 into 1 minus y into 2 minus y is greater than equal to 0. So you take 1 minus y into 1 minus y minus 8 plus 4y greater than equal to 0. So this will become 1 minus y into 3y minus 7 greater than equal to 0. Till here we have written. Now we see that this will give you the critical points 1 and 7 by 3. Now if we take a value beyond 7 by 3, so since coefficient of y is negative here and positive here, so this will be negative, positive, negative, and we have to take greater than equal to 0. So 1 comma 7 by 3, that means if we want to take the interval, then it is 1 comma 7 by 3. And of course, if we take y is equal to 1, from here we are getting y belonging to 1 comma 7 by 3. And if we take y is equal to 1, there would be a problem. If we take y is equal to 1, what will happen? This will become 0, this will become 0, and this will become 1, which is of course not equal to 0. So we have to exclude y. So y cannot be taken into the interval. So it is 1 excluded till 7 by 3. Now let us come to the next question. Find the periods of the following functions. So how do we find the periods? That is the fundamental period. This function will have the period 2 pi by 2 pi by 3. And this function will have the period 2 pi by 2. So what we are getting here? We are getting 3 for this one and we are getting 4 for this one. So the LCM of 3 and 4 we will take. So LCM of 3 and 4 will be 12. Similarly, if we take tan 3x here, then it is pi by 3. And we take cos 5x by 2, then it is 2 pi by 5 by 2. The period is there. As we know that if there is a function fx, its fundamental period is t, then f of ax plus b, its fundamental period is t by mod a. So we are using the same concept here. Linear extension of x is ax plus b. Now this will become pi by 3 and this will become 4 pi by 5. Now we take LCM of 1 and 4. So LCM of 1 and 4 will be 4, and HCF of 3 and 5, that will be 1. So 4 pi is the result which we are getting here as the LCM of both of them. So we are taking LCM of this one with this one, and we are taking the LCM of the numerator by HCF of the denominator. Now let us come to the next question. It is given, let the function g be given by this one, then g is even and strictly increasing in 0 comma infinity, odd and strictly decreasing in minus infinity comma infinity, odd and strictly increasing in minus infinity comma infinity, neither even nor odd but strictly increasing in minus infinity comma infinity. So if we talk about these conditions, first of all, odd and even. So if we take g of minus u, what will happen? 2 tan inverse e to the power minus u minus pi by 2. This will become 2 tan inverse 1 by e to the power u minus pi by 2, right? Now tan inverse of 1 by x is equal to cot inverse of x. So this is cot inverse of e to the power u minus pi by 2. Now cot inverse of e to the power u is this one, and we can write it as pi by 2 minus tan inverse of e to the power u, and minus pi by 2 is outside. So what will happen? Pi minus pi by 2 is pi by 2, and there will be minus 2 tan inverse e to the power u. So this is what we are getting here. So if you observe, this is actually minus g of u. This is gu, and that is actually minus g of u, that is pi by 2 minus 2 tan inverse u. So first of all, we can say that this is an odd function. It is odd. Further, about increasing, decreasing. So you have to differentiate it. When you will differentiate it, what will happen? F dash of u, or here it is g, so g dash of u. So it will become 2 by 1 plus e to the power 2u, and derivative of e to the power u is e to the power u. So this is what we are getting here. Now this function, for all values of u from minus infinity to infinity, is actually positive. So this is always greater than 0. So we can say it is strictly increasing, because the derivative is positive, so it is strictly increasing, and also it is odd function. So we will say that option C is the correct option. So this is the next question, students. Show that x to the power y is greater than y to the power x for all xy such that 3 is less than equal to x less than y. Now if we take the function here, that function is f of x is equal to x to the power 1 by x. Now this function we are taking here. Now let us take it as u, and we take log of u. So that is 1 by x log of x. Now when we take the derivative 1 by u du by dx, it will be equal to 1 by x square plus log x into minus 1 by x square, like this. So this will be 1 minus log x by x square. Now this is du by dx. We have du by dx is u, which is x to the power 1 by x upon x square into 1 minus log of x. Now we have x is greater than equal to 3. Now if we have x is greater than equal to 3, and we know that log of e is equal to 1, and log of 3 is actually greater than log of e, so it is greater than 1. So we can say that 1 minus log x is actually, so because log x is greater than equal to 3, log 3, so we can say that x is greater than equal to, log x is greater than equal to 1, which means 1 minus log x is less than 1, not equal to here, because there is no equality in between there. So we can eliminate this equality, as here between these two there is a greater than sign, not equal to sign. So 1 minus log x is less than 0. So if we take 1 minus log x, a negative quantity, and we have du by dx is equal to x to the power x, which is a positive quantity, and x square is also a positive quantity, it is less than 0. So which type of function is? It is a decreasing function. Now in this decreasing function, if you observe that if this is a decreasing function, then we can say that x to the power 1 by x is actually greater than y to the power 1 by y, where y is greater than x. As the input is increasing, the output is decreasing. So we say that x to the power y is greater than y to the power x. So x to the power y is greater than y to the power x. That is what we had to prove. So that is all for this, students. Thank you.